because if you scan this, it will take you to Knative tutorial link, and on that link you have access to the slides, and you also have access to the tutorial that I'm going to show you. There's also another link, Cloud Run tutorial, that I just finished, and I'm going to put it on GitHub. It's not there yet, but it will be on Monday. So if you want to learn more about Cloud Run 2, there will be a tutorial there too. And I'm going to be showing a few demos. So if you want to see the demos, you probably want to be closer because the screen is a little small, but you can also listen. It's up to you. All right? All right, so let's do a little bit of introduction. What is Knative? Knative, it's a Kubernetes-based open source building blocks for serverless. Who is here using Kubernetes? Anyone? A few people. Okay. So if you know about Kubernetes, this sentence doesn't really make sense. Because in Kubernetes, you have what's called nodes. So these nodes are very much servers. So you can't really talk about serverless and Kubernetes in the same sentence, but that's the whole point of Knative. Knative tries to treat Kubernetes, it tries to make Kubernetes, turn it into a serverless framework, basically. Yeah. So once you install Knative, you can almost treat Kubernetes as a serverless framework, and we'll go through the presentation and see how that works. Now, what do we mean by serverless? I mean, if we ask 10 people this question, we'll probably get 10 different answers. But I think generally there's two different ways of thinking about serverless. One is the operational model, so how you run your code. Usually when we think of serverless, we think about no infrastructure management. So there are servers somewhere and someone manages them, but it's not really your problem anymore, which is nice, at least for me. The security is usually managed at least at some level, not wholly, but at some level. And you probably expect that you will only pay for the usage, so you don't pay for the server all the time, just for what you use. Now at the same time, if you're an application developer like me, there's a programming model way of thinking serverless. So when you talk about serverless, you're usually talking about service-based things. So you're talking about services that are event-driven, so something triggers your service rather than calling it synchronously. And usually we talk about stateless services, because when you have stateless services, things become much more difficult and it becomes much more difficult to scale down and scale up. So usually these are stateless services. And then we have these things called containers. Who's here using containers? Okay, almost everyone. As you know, containers, it's all about how you package and you run your application. And the good thing about containers is that you can pretty much use any language you want, any library you want, any binary you want. And there's this nice ecosystem around containers. So you have these base images that you can build on top of. But at the same time, you have all these projects, Kubernetes, Istio, Knative, and others, that makes running containers at scale easier. At least that's what they try to do. And when you look at Kubernetes, for those of you who are not using Kubernetes, just a recap, there's a lot of stuff happening in Kubernetes. So if you want to deploy a service on Kubernetes, you need to do a lot of things. First, you need to push your container image to a registry. Then from there, you need to create what's called a pod template. A pod is the smallest unit that gets scheduled in Kubernetes. Usually it's a single container, but it can be multiple containers. Then you tell Kubernetes what you want. In this case, we're telling the replica set in Kubernetes that we want 3 replicas. Kubernetes looks at the nodes, the servers that you have, and it schedules these pods. Then these pods are running, you can label them. Once you want to expose them to the outside world, you create what's called the Kubernetes service, and then people from outside will get to your service, and from the service will get to your pods, from the pods will get to your code. So once you know Kubernetes, this makes sense, but there's a lot of things that you need to do, right? It's not that straightforward. You can't just deploy your code and that's it, everything runs. You have to think about these things. So when you think about it, containers gives us all this flexibility that we can choose any language we want, use any library we want. But at the same time, with that flexibility comes the complexity that you have to deal with Docker files, with Kubernetes, and all the technologies around it. On the other hand, serverless gives you velocity, right? When you deploy your code, you just say, here's my code, deploy it, and then all the details of running the code, scaling the code, all that kind of things are taken care of for you. So you can go much faster, but you don't have the flexibility of the containers. And that's the problem there. You need to rely on the cloud provider and see if they support your language, see if they support the version of the language that you want, things like that. So far it's been kind of like a choice of flexibility over velocity, but it doesn't have to be that way, thankfully, now with Knative and Cloud Run. So the Knative project, it's an open source project on GitHub, and it's a set of components that kind of turn Kubernetes into a serverless platform. It started from Google, but now there's a bunch of other companies like IBM and Red Hat and SAP and others that are contributing as well. And Cloud Run is built on top of Knative, and it tries to bring serverless to containers on Google Cloud. So you can think of Knative as the open source project that's kind of the foundation, and Cloud Run is the managed version of that on Google Cloud. So if you're already on Google Cloud, this is probably where you want to start. But if you are out in the open or running your own Kubernetes cluster, or if you're on any cloud provider, maybe Knative is a better choice. Today's talk is mostly about Knative, so I'll talk about the open source Knative, but I'm also going to show you an example of Cloud Run and see how that compares and contrasts with Knative here. So the Knative and Cloud Run stack is kind of like this. At the bottom layer, you have Kubernetes, so everything runs on Kubernetes. Then on top of that, you need to install a gateway. So Knative doesn't really deal with networking problems, so it doesn't really try to figure out how to get traffic to your containers. Instead, it relies on a gateway like Istio or Glue or Ambassador to do that work. And then once you have the Kubernetes and a gateway, you can install Knative on top. There are two parts of Knative, serving and eventing, and we'll go through them one by one. You don't have to use both. You can pick and choose what you want. So you install whatever you need. And there used to be something called Knative Build, but that turned into a separate project called Tecton Pipelines, and we'll talk about that as well. But technically, Tecton Pipelines is not part of Knative anymore. So you have the Knative, and you can use it as is. So anytime you have Kubernetes, you can use all these features of Knative. But as I said, there's bunch of other products that are being built on top of Knative, such as Cloud Run or Cloud Run on Google Cloud, and other products from other cloud providers. So if you are in a cloud provider already, you probably want to check out what they do with Knative. You can still install and use Knative yourself if you want, but it will be probably much easier to use whatever is built on top of Knative. All right, so that's a quick introduction to Knative and Cloud Run world. Now, what I want to do is I want to go through the first part of Knative serving, and show you what it provides, and then we're going to go through Knative eventing, and then depending on how much time we have, hopefully I'll also show you some stuff on Tecton Pipelines. All right, so before we can use Knative serving, we need to first get a Kubernetes cluster. Depending on where you are, you have different ways of getting a Kubernetes cluster, but on Google Cloud, this is how you do it. You just use a gcloud command line tool to get the cluster. One thing to note is that here I'm specifying an add-on, and I'm saying Istio. So this command gives me a Kubernetes cluster with Istio already installed. So I already have my prerequisite for Knative already installed for me. Then we need to create a cluster role binding, so that's needed to be able to use Knative for networking. Then you need to install Knative. This is all, by the way. The latest version of Knative is 0.10.0. So you basically just point to the YAML files of the Knative that you want to install. In this case, I'm pointing to server.yaml to install serving. Then I'm pointing to release.yaml of eventing to install eventing. And you can also install some monitoring things on top of Knative so you can monitor what's happening in Knative. So basically, get a Kubernetes cluster, install Istio, and then install Knative on top, the parts that you need. One thing that you need to pay attention to is that different versions of Knative have different dependencies on different versions of Kubernetes and Istio. So you need to make sure that those version numbers are correct. Or you can use Cloud Run, and you don't have to worry about version numbers, and I'll show you that. Okay, so what is Knative serving? In a really quick way, Knative serving, it lets you deploy containers in a serverless way, right? And what I mean by that is that you basically create what's called a Knative service, and then in this Knative service, you point to your container image, and then you also specify a very simple configuration. and then you tell Knative, just deploy this container for me, and Knative takes that service definition, and it deploys your container in a pod. Then it sets up the traffic, so that pod has a public IP, and people can get to that URL. And then it gives you automatic scaling, so that pod will be running on that container will be running on a single pod, but it will be automatically scaled up to n that you define, and it will scale down to 0 if no one uses it in 60 seconds. And then you get a basic configuration and revision management, so you can get multiple revisions of your service as you make changes, and then you can do traffic splitting between those revisions. So in a nutshell, it lets you deploy a container in a really easy way, get automatic scaling, get revision management, and traffic splitting, okay? And the terminology of Knative serving is something like this. At the top level, you have a service. This is a Knative service. It's not a Kubernetes service. It's something higher level. So that's a Knative service that has a configuration that points to an image and other things like environment variables. Then you deploy the service and the configuration combination, and that gives you a revision. And then Knative also creates a route to point to that revision, so all the traffic will go to the latest revision. And anytime you make a change to the configuration and deploy again, it will create a new revision, and the route will be updated to point to that revision. So that's the default case. But then once you have multiple revisions, you can also set rules here, and you can say, okay, I want this revision to get 50% of traffic, I want this revision to get the other 50%. So service, configuration, and revision are the things that you think about when you deploy Knative. So let me show you some examples of this. So let's see how this is going to work. Let's see if I can put it. Great. So as I mentioned, I have a tutorial on GitHub, so I'm just going to pick and choose some parts of this to show you how Knative works. We already installed Knative, so I'll just make sure that everything is running. So if I go to my Kubernetes cluster, I say kubectl get pods. Knative gets installed into separate namespaces, so let's check Knative serving first. So I'm just looking at the case Knative serving pods and they're running, that's good. And then let's also check the Knative eventing pods if they are running. So Knative eventing pods are running as well. So my Knative is installing Kubernetes and they're all running. And now here I'm looking at some pods in my cluster. You can see that I have some default pods, broker pods. These are pods that get installed when you set up Knative eventing. So I set them up before the talk, so that we have to set them up. But they're running as well, so all is good. Now to deploy a service on Knative, first what we need to do is we need to create our code, and in this case I'm just going to deploy a very simple hello world service. In this service what we're going to do is, in my tutorial I use C# and Python, but you can use whatever you want. What I'm doing is that just to show you, I am first of all binding 000 and port 8080. That's the default way of binding to a service in Knative. And then the second thing that I'm doing in startup is that I'm looking, so when I get a request for the default path, I am looking for an environment variable called target, and if there is one, then I will say hello target. And if there is no one, then I'll just say hello world. So it's something very simple, but I do it on purpose because I want to show you what Knative does rather than the example itself. So I build my image, I push to Docker Hub, then I need to create my Knative service. To create a Knative service, it's a YAML file, as it is in every Kubernetes thing. So I create a YAML file. But one thing to note is that this is using Knative API. And the kind is service, so it's a Knative service. I give it a name, I specify where I want to deploy this. I'm going to deploy it in the default namespace. And this is the configuration of my service. The configuration points to the image that I pushed, and it also specifies the environment variable target and p1. So that's what we're going to read and print out. Now to deploy the service, I'll just say kubectl apply. So let's just do that. So before I do that, let me make it a little bigger. Let me watch something. So what I'm watching here is that I'm watching Kubernetes pods, Knative service, Knative configuration, Knative revision, and Knative route. Now, right now, as I told you before, there's some pods that are running from for my eventing, so we can ignore them for now. But to deploy my service, I'll say kubectl apply service v1. Now this creates the Knative service, and then we'll see immediately that there's a Knative service that's being defined, and there's a pod for my service that's been running, there's a configuration that's been created as well, and I need to make this a little bit smaller. And then you can also see that there's a revision, the first revision that's been created, and the route is also set up. So the traffic is already going to my service. So all the things that I talked about with Knative serving is already created. And if I go to curl and just hit that URL that I set up, it says hello v1, right? So our service is up and running. Now every time I make a change, so let's close this. Let's close this too. So every time I change anything in the configuration, it will create a new revision and update the route to the revision. So let's actually do that. So I come to my service and change my environment from version 1 to version 2 and deploy again. So let's do that. So let's service v2. And then you'll see that as soon as this is applied, Knative realizes that there's a change. Then it will hopefully, yes, it created a new revision, so this is a revision 2, and then it created a new pod for that as well, so I have now 2 pods running, one for version 1 and the one for version 2, and the route is updated as well. So if I do a curl again, now it should say hello v2, so we did an update to our service. Same thing with the code changes. Let's say you want to change your code and deploy. To do that, you need to go to your code, and in this case, I just changed my message from hello to bye. So now I'm going to say bye v1 or v2 or whatever. So I build my image, I push my image to Docker Hub, then I come to my service, and then I change the image from version 1 to version 3 and apply the change. So I'm basically pushing a code change. Let's do that. And then this will create a new revision. It will update the route to point to that revision. And once the code is running, it will get the new code. Now, one thing that you're going to realize is that we have 2 pods running now for Hello World. So one is for version 2, the other one is for version 3, but the one for version 1 is scaled down because no one used it for 60 seconds. So it's scaled down to 0. And that's the nice thing about Knative is that scaling is automatic. So if I do another curl, now it says by v3. I did a code change. Obviously, you don't do this kind of code changes in real life. What you should be doing is that you should do a silent deploy of your code, make sure that the code actually works, and then gradually send traffic to it. And then once you know that it's working, let's say with 50% of the people, then maybe you will send 100% of the traffic. So you want to do blue-green deployments or traffic splitting, things like that. And Knative makes that quite easy. So the first thing that Knative gives you is that the revision names so far, if you look at our revisions, they have random names because we didn't give them any name. But if you go to your service and then under here, template, you can actually name your revisions. So in this case, I'm deploying the same version 1 on my image, but I'm giving it a name called hello world-v1. So when I deploy this, it will have a predictable revision name. This is important because once I have predictable version names, I can do traffic splitting much easier. So I give it a name, and then I also specify some traffic rules. So in here, I'm saying that the hello world-v1 revision will get 100% of the traffic, and then anything else I deploy afterwards will not get any traffic. So if I deploy something afterwards, you won't get any traffic. So let's actually see this. So kubectl apply service v1, and I call this int. So this will deploy back to version 1, but the difference is that the revision that will get deployed, now if you look at here, it says hello world v1, so it has a predictable name. And if I do a curl again, we are back to version 1, which is good. Let's deploy a new version, now this time version 4. This will also have a predictable name, so here you can see that version 4 is being deployed as well. But remember, the rule says that anything that gets deployed after my version 1 won't get any traffic. So if I do a curl again, it will say hello v1, right? So I did a silent deploy of version 4, and it is deployed, because if I go to this URL, and if I add latest dash at the beginning, I can get to version 4, right? So I can test it out, but the main URL still points to version 1. So that way you can do silent deploys and test things out and make sure that it works. Now at some point you probably want it to get some traffic, so for version 4 to get traffic, all you need to do is you just go to traffic rules, and then add a rule that says, okay, version 1 should get 50%, and version 4 should get the other 50%. And if something else is deployed after that, it still should not get any traffic, right? You can set rules like that. So let's actually do that as well. Curl, kubectl, apply, service v1, v4, split. Now this doesn't create anything new because we didn't change it. We didn't deploy a new version. We just updated the routing rule. And then if I do a curl again, now it says hello v4, another curl v4. At some point, yeah, now it says v1. So roughly half of the time it will say v1, the other half it will say v4. All right. So this is how you can do, revision management and traffic splitting native. As I mentioned, if you use your for 60 seconds, things scale down to 0, but all of that is configurable. So auto scaling is totally configurable in Knative. So what I have here is that I have another service called sleeping service that when it gets a request, it just sleeps for 4 seconds. It just simulates that it's doing some work. And then I go to my service and I specify some auto scaling rules. Before I explain this to you, let me deploy this service and then send some traffic to it, and then we can look at the configuration and try to make sense of it. So let me first delete my Knative service, all of my Knative services. So this deletes hello world, and everything should be clear. And why are they running? Yeah, now they're running. Okay. And let's go to sleeping service, and then let's create that. So I just deployed my sleeping service. And then I'm going to use, you can see that the sleeping service will have, well, once it's deployed, it will have one pod running. Now I want to send some traffic to it, so what I want to do is Fortio, I'm using Fortio, which is a tool that you can use for sending traffic, and then just hitting that URL. And now this will start up and it will start sending traffic to this service. Now right now there's only one pod. So now let's look at the configuration. In Knative, the default auto-scaling is concurrency-based auto-scaling. And then the default target is 100, meaning every pod will get 100 requests before it scales up. So if you have 100 requests, it will be one pod. If you have 101, it will be 2 pods, and so on and so forth. In this case, I changed target to 1. So every pod will get 1 request, and the second request will create a new pod. So I just want to simulate, I just want to show you auto-scale. So that's why I lowered this down. And then you can also set minimum scale and maximum scale. So minimum scale is by default 0, meaning everything scales down to 0 if you don't use it. But in this case, I'm setting it to 1, meaning there will always be one pod running. And sometimes you want this. If your service, if your container takes a while to start, yeah, it's good to have a minimum 1 so that you always have 1 running. And I also set a scale 5 or 6 in this case, so that I will have 5 or 6 pods at max, no matter how much traffic I send to it. Also, the type of auto-scaling can be configurable, so instead of having concurrency-based auto-scaling, you can have CPU-based auto-scaling, and Knative would set CPU instead of concurrency to the scale. So we did this, and I started sending traffic, and then you can see that I have 4 services now, that it scaled up because of my requests. I think there's a bug in Knative in the latest version, 0.10. For some reason, whenever I set the limit 5, it scales up to 4, but not 5, and I couldn't figure out why, so I need to debug this further, but there's a bug here somewhere. But you can see the idea is that you can set the rules, and for the most part, it works. So let's kill this. All right, and let me delete my service, because I don't need it anymore. All right, so that's auto-scaling.
And now what I want to show you is, so far, everything I showed is on Knative. And this works everywhere you have Kubernetes. So no matter where you run Kubernetes, whether it's on-prem or Google Cloud or some other cloud, it works. Now, as I mentioned, on Google Cloud, there's something called Cloud, which you can think of as the managed version of Knative, and there's another version called Cloud Run on Untitled, which is Cloud Run on managed Kubernetes. So you have choice on how you can run Knative, and I just want to show you a quick demo of Cloud Run and see how it works on Google Cloud, just to give you an idea. So in this case, first of all, Cloud Run, it just went GA, by the way, just a couple of days ago. But I think these are the regions that are supported today: US Central, US East, Europe West, and Asia Northeast, last time I checked. So you need to have a project in one of these places. Then you need to have your image in Google Container Registry. So Google Container Registry is a private space for your Docker images that you can use. And if you do gcloud build submit in the same place where your Docker file is, and then just tag your image like this, this will basically build your image using Cloud Build in Google Cloud, and it will save it to Google Container Registry. So with a single command, you can build and save it. And actually, if you look at it, I go to my container registry. Under here, I have Hello World, and under here, I should see V1. So my image is already there. I already built it beforehand. And then to deploy it, you would say gcloud. You don't need to do beta anymore. I need to update my tutorial. Gcloud run deploy, and just point to your image. So let's actually do this and see how it works. Kill this. So I'm just saying gcloud beta. No, let's get rid of beta. See if it works. Gcloud run deploy and point to my image. Now it's asking me where you want to deploy it. Cloud Run fully managed, Outpost, VMware, and or exit. I want to deploy to fully managed. Service name is Hello World. And now you'll see that, okay, it's also asking me, do you want unauthenticated invocation? So you want your service to be open to everyone, and I want yes. And now it's saying deploying the new service, creating a revision, routing traffic to the revision. So all the stuff that I show you with Knative, it's doing the same thing. But the big difference in this case is that I didn't create a cluster, I didn't install Istio, I didn't install Knative or anything like that. I just said, okay, just deploy this, and now I already have a URL. And if we actually go back to Google Cloud Console and Cloud Run, now I don't have to think about Kubernetes clusters anymore. You can see that I have a few different services. And then here, this Hello World is the one that I think I just deployed. And if we look at other revisions, you see that there's a revision. It's deployed just now. You can see the details, the YAML, it's just a Knative service. You can look at the metrics. So we don't have anything to show here, but basically you can look at stuff like request counts, latencies. It has integration with Stackdriver, so you can see the logs of your service right in the console. And then once it loads, but it also gives you a default URL, so you don't have to set up your own domain. And then if you click on the URL, it should still say Hello World, right? So it's the same thing, except on fully managed Cloud Run, okay? So it's the same kind of experience, except it's just much more managed than doing Knative by yourself. All right, let me see what else I have here. So that's Cloud Run, and then, one last thing I want to mention with Knative serving is that what we deployed so far, they're all public, right? So they're public services with URLs, but it doesn't have to be that way. You can actually have private services, and to do that is you go to your service and you add a label called cluster local label. And once you add that label, your service ends up having a private URL instead of a public URL. And I think I have an example of this, so let's actually take a look. So for example, if you look at the Hello World service now, it has I use nip.io as a dummy domain for my service, but it has basically a public URL. But if I deploy a private one, let's see, Hello World, let's say apply service local. Now this creates a new service called Hello World Local, And then if you look at the services that we have, you see that this hello world local, it doesn't have the public lib.io URL. Instead, it has a cluster URL that only the services within the cluster can get to, but no one else. So you can do stuff like that if you want. I think that's all I want to show in terms of Knative serving. And next is Knative eventing. Check that time. All right. All right, so that's Knative serving. The second part of Knative is Knative eventing. And what Knative eventing tries to do is that it tries to give you the building blocks to connect your Knative services or Kubernetes services to different kinds of event sources, right? And these event sources, they can be a bunch of different things. So for example, you can listen Kafka messages, you can listen Google Cloud PubSub messages, you can listen Google Cloud Storage events, and many more. This is not the full list. And the way it works is that first, in Knative, depending on what you want to listen, let's say, for example, you want to listen to Google Cloud PubSub messages, that creates something called a source. So these sources there, I think they're misnamed. They should be called source importers. So they basically import whatever kind of event you want to listen. So that source pulls the events into your cluster. And then you create a broker in your namespace. So whatever namespace should get these messages, should create a broker in that namespace. The broker gets the messages, and it will eventually pass it to a service. These services can be anything that's callable. So it can be a Kubernetes service or Knative service. I usually use Knative services because they're easier. But before a broker can pass these messages to the service, it passes them through what's called a trigger. A trigger is a way to filter some messages so that not all your services get all of the messages. And it also makes this connection from broker to the service. So that's where we define the connection. Right, so the source pulls the message in, and then in the namespace broker gets the message, and then from there, trigger filters it, and then eventually your service gets the message, and then do whatever it wants to do with the message. I should also mention that, when you think about it, there's all sorts of different kinds of messages that's coming into your system, but eventually they get converted into what's called cloud events. And this cloud event, it's an open source event definition, so they will all have similar metadata with ID and time and stuff like that, but the data of your cloud event will have the actual payload that you are interested in. So I have one example of this that I want to show you. In this case, what I'm trying to do is that I'm trying to connect Google Cloud Storage events to Vision API using Knative eventing in the middle, right? So the idea is that users, either from their desktops or mobiles, they upload an image to a storage bucket, and then in Google Cloud Storage, you can set it so that when something happens in that bucket, like someone's saving an image, it can send a notification to a topic that you define. So that sends a notification to Google Cloud PubSub topic. Then I made Knative eventing, listen to the topic, and pull that message in. Then that gets passed through the broker and trigger to a Knative service. And in this service, I make a call to the Vision API, and I classify that image. So Vision API is a machine learning API to classify images using machine learning. So it will extract the labels of this image, and it will log them out so that we can see what the image is about. But the important bit here is that this thing in the middle, Knative serving and eventing, it's still the work of connecting these two separate services. And everything is running in Google Cloud, but it doesn't have to be. Knative part can live anywhere, really. So to set this up, what do we need to do? So first, maybe I should show you. So first, I need to create my service that will actually get the message. In this case, maybe I'll show you briefly the code. I created in C# and Python, but again, you can use whatever you want. But what I'm doing is it's basically will get some kind of content, and I check this content is the messages the trigger that the storage will send to my service, and I check that trigger. If it's storage object, then I read it, otherwise I won't read it. Then from this trigger, I figure out the URL that the image lives, so this is the storage URL. And then from there, I create a Vision client, so this is the client to talk to Vision API. And then I pass in the storage URL on my image and extract labels. So the tag labels async basically says, go to this image URL and extract the labels of this image. I get some labels back from Vision API. I order them with the scores, and then eventually I will log them out, right? So this is my service. I built a Docker image and push it to the Docker Hub. Then I create my Vision service. In this case, it's just like before. The only thing is that I'm setting minimum scale to 1 so that I have 1 running at all times. And then I need to create a trigger. So my service is running, but I need to connect it to my broker in my namespace. And to do that, I create a trigger. And in the trigger, I basically say, this is the service that you should send the messages to. So this connects the broker to the service, in this case, Vision. And then there's all these details about the bucket. So I create the bucket, I enable notifications on the bucket. We don't have to worry about the details of that. So let's actually look at this. One thing to look is that, first of all, if I do kubectl get broker, you should see that there's a broker in my default namespace already set up. I set this up beforehand. And actually, if you do kubectl get pods, you should see some broker pods already running in my namespace, right? So these are the things that are listening for external messages already. I set this up because it takes kind of a little bit of time to set up. Now, what I want to do is, let's go back to eventing. And go to Vision. So first, let's create our service. So Knative service. And then let's create the trigger as well. All right, and then if you look at it again, so if we do kubectl get pods, you see that I have a Vision pod running. And let's look at the logs of this actually. So if you look at the logs, and I will replace this with the Vision one. Now this service, it's a .NET Core service running on port 8080. It's just waiting for something to happen, right? So just a service that's kind of waiting for something to happen. But we need to trigger an event so that the whole chain is triggered. And for that, I need to send an image. So let's go back to our console. And here, if I look at storage, there's a bucket here called Knative bucket that I set up beforehand. And I'll just upload a file here. In this case, let's upload, I don't know if you can see, but it's basically a beach with some kind of sunset. So now, as we upload this will go to Google Cloud Storage. That will trigger a pop-up message to a topic that we defined. And that message will be read into Knative eventing. And then from Knative eventing, we'll go to broker, and then trigger, and then eventually get to service. And if everything worked, the service will make a call to Vision API with this URL, and it will get the labels out of this image, right? So let's see if that worked. Yes. So if you look at the logs of our service, you see that it received the content. So this is the actual message that it received. And then from here, it extracted the storage URL. So this is the public URL for my image. And then it made a call to Vision API. And then it says, this picture is labeled sky, body of water, sea, nature, coast, water, sunset, blah, blah, blah. But the important bit is that we connected storage events to Vision API using Knative event. All right. That's it for Knative eventing. I have much more samples on my tutorial, so feel free to check out if you want. And let's see how much time I have. I have fun. 4 minutes, maybe 5 minutes. I just want to briefly cover building as well, because so far we talked about how do you serve an image that you have on Docker Hub, but how do you actually get that image to Docker Hub, or how do you actually build things, your services in the first place? There used to be something called Knative build before 0.8, so two releases ago there was something called Knative build that was all about how to get from source code to an image in a repository, right? But then people working on Knative, we kind of realized that Knative build it's not just about building, it's kind of like pipelines, right? And in that pipeline, you can build images, but you can do other things as well. So since then, a new project was born called Tecton Pipelines, and it's all about building pipelines on top of Kubernetes. So in Tecton, you have these primitives, task, where you define what happens in your in the job. And this task can be building a container image. Then you create a task run to actually run that task with inputs and outputs. Like, this is the image, this is the source that I want to build, and this is the output where I want to say, like, Docker Hub. Then you create a pipeline of multiple task runs, and you can use service accounts to authenticate with places like Docker Hub. So you can use Tecton basically to build things like this. And I just want to show you a quick example of, let's say you want to build a Docker image and push to Google Container Registry so that you can use that image in your Knative services. How can you do that? Let's just take a look. So I'll just go back to my tutorial, and in here, there is, so I have the Knative build stuff, but they're kind of deprecated now. But if you look at Hello World build, so first we need to define a task in Tecton. And this task, I won't bore you with the details, but basically it uses an open source project called Canico to build a Docker image, right? So this task defines that. And then I need to define a task run to actually run this task. So in this task run, first you need to define your inputs and outputs, and these are called pipeline resources. And in this case, one of my pipeline resources, what I want to build, which is my Knative tutorial. And then the other pipeline resources is what I want to produce. In this case, where is the image location? And this is gcr.io and my project ID. So that's where I'm going to save my image. Then in the task run, you basically point to your task that you want to run. So the task is the task that we defined before. And then you define your parameters, so your inputs and outputs. So input is my my source, and the output is my the place that I want to save my image. Then to actually run this, you apply just like any other Kubernetes resource, and this creates the resources and task run, and then you can look at it using get Tecton pipelines, the progress, and then once everything is done, you can see a pod that's running and completed. Once this pod is completed, you know that your build is done. You can check and make sure that it works. It's in the container registry. So that's kind of in a nutshell. I don't want to run it now because I don't have time. But one last thing to point out is that if you need to authenticate, for example, in Docker Hub, if you need to push something to Docker Hub, you need to authenticate. You can do that by creating a secret in Kubernetes, then creating a service account that uses the secret. And then in your task run, all you need to do is go to your task run, and then at some point here, you need to point to a service account that you created. So you refer to your service account, and this does the authentication for your for pushing the image. All right, so that's all I have. As I said, if you want to get access to this tutorial and this presentation is here. Cloud Run tutorial will be there on Monday. Knative page, Google Cloud Run page. Yeah, thanks for listening. And I don't know if you have any time for questions, maybe. I don't know. But if not, I'm going to be around, so you can also find me and ask me questions. Thanks very much. Do we have time for questions, or should I? Offline, okay. Yeah, I'll be around then, and please find me for questions. Thanks.